Today, we're diving deep into the cosmic ocean to explore 10 of the biggest threats lurking in the universe. We like to think of Earth as a safe haven, a cosmic cradle, but the reality is, space is teeming with powerful forces and celestial bodies that could disrupt life as we know it. We're talking asteroids, solar flares, black holes, oh my. We'll delve into the science behind these phenomena, examine historical events, and look at how these cosmic events could impact our planet and our future. Buckle up, because we're embarking on an exciting journey through the cosmos, uncovering the awesome and sometimes terrifying power of the universe. You see, understanding these threats isn't about living in fear. It's about appreciating the delicate balance of our existence and the importance of continued scientific research. By studying these cosmic events, we gain valuable insights into our own planet, the solar system, and the universe as a whole. So let's ignite our curiosity, our imagination, and journey into the heart of these celestial dangers, shall we? Let's start with a bang, literally. Asteroids, these leftovers from the early solar system, are constantly whizzing around, and sometimes their path crosses Earth's. Most of them are small and burn up harmlessly in our atmosphere, creating those beautiful shooting stars we sometimes see. But every once in a while a big one comes along. We're talking several kilometers across, the kind that could spell disaster for life on Earth. Remember the dinosaurs? Yeah, they learned about asteroid impacts the hard way. About 66 million years ago, a massive asteroid slammed into Earth, triggering catastrophic events that led to their extinction. The good news is, such events are incredibly rare. But, and this is a big but, even smaller asteroids can cause significant damage. In 1908, a relatively small asteroid about 100 feet across exploded over Tunguska in Siberia, flattening trees over an area twice the size of New York City. The energy released was hundreds of times greater than the atomic bomb dropped on Hiroshima. So asteroid impacts are a serious threat, but let's not panic just yet. Scientists are actively tracking thousands of asteroids, calculating their trajectories, and assessing the risk they pose to Earth. We're developing technologies to deflect, or even destroy asteroids that might be on a collision course with our planet. Our sun. It's the source of life in our solar system. But the sun has its moods, and it throws solar flares. These are intense bursts of radiation, releasing tremendous energy. Luckily, Earth's atmosphere and magnetic field protect us, but solar flares can mess with our technology. They can disrupt radio signals, knock out power grids, and disable GPS systems. A powerful solar storm can cause such chaos. We've talked about asteroids and solar flares, but let's move on to something more extreme, shall we? Let's talk about gamma-ray bursts. These are some of the most powerful explosions in the universe, making supernovas look like firecrackers. Imagine focusing all the energy of a star into a beam just a few miles wide, and then blasting it out into space. The good news is gamma-ray bursts are incredibly rare. But there's a catch. If a gamma-ray burst were to occur within a few thousand light-years of Earth, and that's a big if, that beam were pointed our way, well, it wouldn't be good. I mean, it wouldn't just be bad, it would be catastrophic. The vastness of space is both awe-inspiring and humbling. Gamma-ray bursts remind us that we are but a small, fragile planet in a universe full of both breathtaking creation and equally breathtaking destruction. Let's delve into one of the most fascinating and terrifying objects in the universe: black holes. These cosmic monsters are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Imagine a place where the very fabric of space-time is curved to its limits. We can't directly observe black holes, but we can see their effects on their surroundings. That's what happens when a black hole interacts with nearby stars and gas clouds. But before you start packing your bags and running for the cosmic hills, remember, the chances of a black hole encountering our solar system are astronomically small. Black holes exist, lurking in the darkness, but the universe is a vast place, and the odds of a close encounter are infinitesimally small. Now let's shift from known cosmic phenomena to something more speculative: alien invasions. Is there life beyond Earth? It's a question that has fascinated humanity for centuries. And if there is life out there, could it be intelligent? And more importantly, could it be hostile? The universe is a vast and mysterious place. So, it's not unreasonable to think that we might not be alone in this vast cosmic ocean. Would they see Earth as a source of resources to exploit? And that suggests to me that perhaps intelligent life in the universe isn't inherently driven by a lust for conquest and destruction. We've talked about asteroids and comets, but what about entire planets wandering through space? Imagine a planet, ejected from its star system, hurtling through the vastness of space. We call them rogue planets, and they're like cosmic nomads, unbound by the gravitational tethers of a star. They drift through interstellar space, silent, invisible to the naked eye, but posing a very real threat. You see, our solar system is a fairly orderly place, with planets orbiting the sun in a predictable manner. But a rogue planet could disrupt that order, its gravity throwing everything into chaos. A close encounter, or even a collision, isn't out of the question. The vastness of space makes such events rare, but not impossible. And the consequences? Well, let's just say it wouldn't be good for life on Earth. Imagine gravitational tides, disrupted planetary orbits. It would be a cosmic catastrophe of epic proportions. But hey, it's not all doom and gloom. The very existence of rogue planets tells us something profound about the universe. It tells us that our orderly solar system isn't the only way planetary systems can exist. It points to the chaotic beauty of the cosmos, a place where even planets can become wanderers in the night. Stars, these giant balls of burning gas, seem eternal, right? But even stars have their time, and some of them go out with a bang, a really, really big bang called a supernova. A supernova is the explosive death of a star, an event so bright it can outshine an entire galaxy. But don't worry, our sun is too small to become a supernova. It will die a much quieter death, billions of years from now. But there are other stars out there, massive ones, and when they reach the end of their lives, they go supernova, releasing unimaginable amounts of energy. If a supernova were to occur relatively close to Earth, say, within a few dozen light years, it would be bad news for us. The intense radiation from a supernova could deplete our ozone layer, exposing us to harmful cosmic rays, and it's not just the radiation. A supernova also releases powerful shock waves that can travel through space, disrupting magnetic fields, and potentially even triggering star formation. So, while supernovas are essential for the cosmic cycle of life and death, they serve as a stark reminder of the awesome power of the universe. Space, as we're learning, is an amazing but dangerous place. One of the biggest threats lurking out there is something you can't see, smell, or taste: cosmic radiation. Cosmic radiation is high-energy particles, mostly protons and atomic nuclei, that zip through space at near light speed. They come from all sorts of cosmic sources like the sun, distant galaxies, and even those supernova explosions we just talked about. Here on Earth, we're shielded from the worst of it by our atmosphere and magnetic field. But in space, it's a different story. Astronauts on the International Space Station, for example, are exposed to much higher levels of radiation than we are down here on the surface. Prolonged exposure to cosmic radiation can damage DNA, increase the risk of cancer, and cause other health problems. And it's not just astronauts who are at risk. As we venture further out into space, say on a mission to Mars, protecting against cosmic radiation will be a major challenge. Think about it. Designing spacecraft with adequate shielding, developing new materials that can block radiation, these are just some of the hurdles we need to overcome. Space exploration is a risky business, but it's a risk worth taking if we want to unravel the mysteries of the universe and secure our future among the stars. We've talked about threats from deep space, objects of incredible power and size, but some dangers are closer to home. We humans, in our pursuit of exploring and understanding space, well, we've left a bit of a mess behind. There's space junk in orbit. Defunct satellites, spent rocket stages, fragments from collisions, all of it circling Earth at dizzying speeds. You might think, space is vast, what's the big deal? And it's true. The chances of getting hit by a piece of spent rocket while walking down the street are astronomically small, but there's a catch. Those chances increase significantly when we talk about active satellites or, more importantly, the International Space Station. A collision with even a small piece of space debris at those speeds could be catastrophic. Imagine getting hit by a bullet, except that bullet is traveling at 17,000 miles per hour. We're talking punctured modules, damaged systems, and in the worst-case scenario, fatalities. The Kessler syndrome, as it's called, A cascading chain reaction of space debris collisions, creating even more debris, is a very real threat. We're talking about the possibility of being cut off from space, not a pleasant thought. Comets, these icy visitors from the outer reaches of our solar system, have always captivated us with their otherworldly beauty. But don't let that celestial splendor fool you, because these cosmic snowballs pack quite a punch. We often talk about asteroids and how they pose a threat, but comets carry their own set of worries. First, they're often larger than asteroids, sometimes much larger. And then there's the speed. Comets, flung inwards by the gravitational tug-of-war of the outer planets, can hurtle toward the sun at incredible speeds. We're talking impact speeds that make asteroids look downright sluggish. The good news is, thanks to the vastness of space, a direct comet impact is thankfully a fairly rare event. But there's a catch. Comets are often unpredictable. Their orbits can be influenced by the gravity of planets, nudging them onto new and potentially dangerous trajectories. Unlike asteroids, which are mostly rock and metal, comets are a mixture of ice, dust, and rock. This means that even if a comet doesn't directly hit Earth, a close encounter could still spell trouble. The sun's heat can cause a comet to break apart, creating a debris field that could rain down on our planet. That's not a meteor shower you want to be around for. From rogue planets to gamma-ray bursts, we've covered some of the most amazing and, let's be honest, terrifying threats lurking in space. It makes you want to hide under the covers with a good book, but let's not be paralyzed by existential dread. Remember, the universe is an incredibly vast and mostly empty place. The probability of any of these cosmic catastrophes happening in our lifetime, or even in the lifetime of our species, is thankfully very small. But that doesn't mean we shouldn't be aware of them, right? Knowledge, after all, is our best defense. So keep looking up, keep asking questions, and keep exploring the wonders of the universe. And if you happen to spot a rogue planet or a comet hurtling our way, you know who to call. Or maybe just tweet about it, because, let's face it, there's not much we can do about it anyway. See you next time. Keep your minds curious, and your telescopes pointed at the stars.